Hi, everyone, and welcome to today's discovery session. These sessions are meant to support students, businesses, and other organizations with an understanding of how to use data and artificial intelligence. But before we begin, I'd like to acknowledge that DeepSense works out of Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq people. This territory is covered by the Treaties of Peace and Friendship. We'd like to recognize the Indigenous peoples of all the lands that we're on today. We want to ask that everyone takes a moment to consider the territory in which they're situated and their own personal responsibility in the processes of reconciliation. My name's Alyssa, and I'm the communications specialist with DeepSense. For those of you who don't know what DeepSense is, let me give you a little bit of an introduction. DeepSense is a project based out of Dalhousie University in Halifax, Nova Scotia, but we work with universities and colleges across Atlantic Canada. We work with companies in the ocean sector who are interested in harnessing the potential of data and creating a smarter ocean economy. We connect these companies with the next generation of AI, machine learning, and data experts, aka you. We work with companies to create a project that best suits their needs, and then we find a researcher and a student to help execute the project as either a master's research project, a co-op, or an internship. We've had past projects in data analytics, data collection, data visualizations, data cleaning and processing, and of course, AI and machine learning. Projects could be anything from creating a deep learning model to track fish, or creating a prediction model for safe navigation in the Halifax Harbor, or even a computer model that can identify whale shapes from aerial images. If you've ever wanted to grow your skills and work on real projects and gain industry experience, then make sure you submit your info to our student pool. Projects and internships and co-ops pop out throughout the year, so it's useful to throw your name in this because it's the first place that we will check to find someone to fill a position. And I'll share a link to the pool in the chat later on. And make sure your resume is in tip-top shape because we want you to stand out, since only those who are selected for an interview will be contacted. And in this discovery session, we're going to dive into the concepts and advantages of cloud computing, debunk misunderstandings surrounding this technology, explore the latest emerging trends, discuss how cloud computing drives innovation and accelerates industry modernization, and provide insightful use cases. And today's discovery session is led by Dr. Liu Yang, and he holds a PhD in computer science from the University of New Brunswick and brings with him a wealth of experience in enterprise-level high-performance computing administration and management, spanning over 15 years. His expertise extends beyond HPC to encompass cloud computing, particularly in the context of ocean AI, data analytics, and cloud architecting projects at DeepSense. Prior to his current instructor role at the Faculty of Computer Science of Dalhousie, Dr. Yang served as the Cloud Solutions Architect at DeepSense, Cloud Solution Engineer at Jewel Labs, and HPC Systems Specialist at AceNet and DeepSense. And if you have any questions throughout the presentation, we'll be taking them at the end, but feel free to drop them in the chat at any point during the presentation, or you can use the question and answer box. And that is enough from me. Let's hear from Dr. Yang.
Thank you, Alyssa. Can everyone see my screen?
Yeah, we can see it.
Okay, thank you. Okay, so thank you everyone for coming to today's discovery session, Driving Industry Innovation, the Transformative Power of Cloud Computing. This is Liu Yang. The target audience for today's talk is basically is everyone. It's not very technical. I want to provide the information about the most emerging technologies and then explain why cloud computing is one of the most emerging technology and why industry people need to learn and use it, and what kind of innovation industries can benefit from the cloud computing. So today's agenda includes that technology trend for industries. I will briefly introduce what cloud computing is. I will explain the benefits of cloud computing, but I also want to explain the misunderstandings about cloud computing from industries. And I want to show you some industry use cases and also tell you how DeepSense can support on cloud computing. Okay, first, let's look at the most emerging technologies. I don't know if you are familiar with the this website, Gartner.com. Gartner is a very famous company generating a lot of research report about technologies. So I like to read their reports to understand the technology trend, then what's the most popular technologies for the coming years. So this helps not only myself, but also say for CIOs, CTOs, and CEOs of the industry people to understand what technology they should be learning, what technology they should adopt. Is it too early to adopt this technology, or is it too late to learn this technology? So it's very helpful for people for the decision making. And on this slide, I'm showing you the hype cycle for emerging technologies for 2023 and beyond. The hype cycle for 2024 is not out yet, so this one is the most recent one. So before we dive into this cycle, let me show you actually all the technologies that are shown in this cycle are listed over here. They are divided into 4 categories. It's not surprising that the when we after we divide them into 4 themes, AI is always at the top, right? AI is the hottest topic right now. So there are so many AI technologies that will be in this hype cycle. You can see generative AI is at the very top, right? And also the second theme is pervasive cloud. In this theme, we have several technologies that is in this cycle: cloud native, cloud out to edge, web assembly, industry cloud platforms, cloud sustainability, cloud development environments, and augmented FinOps. If you don't understand these terms, it's not a problem. I'm going to explain them right now. And there are 2 more themes, developer experience and human-centric security and privacy is not the topic for today. So now let's look at this hype cycle. First, we need to understand this, what hype cycle mean. So the y-axis and the x-axis are represented by expectations and time. And on the horizontally, you're going to see 5 phases: innovation trigger, a peak of inflated expectations, through of disillusionment, and the slope of enlightenment, and the plateau of productivity. So let's look at the technologies under theme 2, pervasive cloud. What we can see, we can find from this cycle. The first one is cloud native. You can see cloud native stays over here. It's in the phase of peak of inflated expectations. That means people are having a very high expectation to adopt cloud native. But what does cloud native mean? Cloud native basically means that when you want to create something or implement something, you are trying to make the best use of cloud characteristics. You are trying to use all the cloud tools instead of other tools. That means cloud native. So let's look at the second one, cloud out to edge. Where is it? It's here. Cloud out to edge. It's also in the phase of a peak of inflated expectations, but it's still rising, right? It's still rising. It's close to the innovation trigger. Cloud out to edge is very, very popular because there are so many edge devices. For example, the watch you wear on your wrist is a kind of edge device. Your data is on the device, and you do the computation on the device. It's because the computation is very close to the data, so you have very low latency. For industries, a lot of industries, especially in the ocean industry, we have a lot of sensors or Internet of Things. So when our sensors are floating in the ocean, we may want our sensors to do the computation within the sensor, but not send the sensor data to any server or the cloud. So cloud out to edge will be very, very popular for a lot of edge devices, Internet of Things. The communication between cloud and edge would be using the optimal protocol for the communication, but all the computation and the data should reside on the edge device or the Internet of Things. The next one is WebAssembly. WebAssembly means that we can run our high performance applications on the web interface or web pages. So I don't have a lot of experience on this, so I don't want to spend much time on this part. The next one is industry cloud platforms. Let's see where it is. Here, it's in here. It's in the phase of innovation trigger. That means it's going to rise. Industry cloud platforms means that the cloud providers will generate industry cloud platforms for different sectors. The platforms will include, say, specific applications, compliance frameworks, and the dedicated databases and solutions to integrate all the components of the cloud services and present the solution to different industries. So this enables the composability of web services, cloud services for different industries. So this is provided by cloud providers, but not by industry. However, industries should be prepared to use the industry cloud platforms in the future to develop their product. So this will give them a lot of convenience, make it very easy to develop the product. The next one is cloud sustainability. So a lot of people don't understand what cloud sustainability means. Cloud sustainability means that we are trying to use cloud resources to reduce, say, the carbon emission, and also to benefit the social and environmental systems. It's going to be very important in the future, but right now, very few people pay attention to cloud sustainability. The next one is cloud development environments. Cloud providers will, here. It's also in the innovation trigger section. Cloud providers will try to provide development environments for developers to make the setup and the configuration of the development environment very easy. So right now, when a lot of developers are using cloud services to develop their products, they already found it so easy, but cloud development environments will make things even easier. So you only need to worry about your coding and your data. You don't need to worry about any environment and the setup and the configurations on the cloud. The next component is augmented FinOps. So it is over here. It's very low. That means there's still a very big space for augmented FinOps to go up to the peak of inflated expectations. So augmented FinOps means that we are trying to use the CI/CD and the DevOps of agile software development and use that in financial operations, financial governance, and the budget and the cost management. This may not be very interested to you right now, but in the future, you may see this again and again, very frequently. Okay, so you can see in this hype cycle, cloud technology and AI technologies almost take all of the emerging technologies. So we can foresee in the future, industries have to adopt the both AI and cloud technologies to get themselves to go beyond the other industries, to move their products forward and keep themselves successful and competitive. So this is a picture of the general technology. Now let's look at cloud technology itself. So this is the future of cloud computing through 2028. So where are we now? We are here. So here you can see the state is that cloud as technology disruptor and cloud as capability enabler. People found that cloud is that new, is not that new right now, but when cloud occurred, people found that this technology could be a disruptor in the whole technology world. And then people found that we can use cloud to do something. The capability of cloud is good. And then after, say, 2024 or 2025, we are approaching this stage until 2028. We will go through cloud as innovation facilitator, cloud as business disruptor, and cloud as business necessity. So that means cloud will be necessary for businesses. It's not for technology development. So in the future, all businesses will be on the cloud. You cannot avoid using cloud. So it's better that you start early. Now I want to introduce a survey that I was supervising in the last term. It's our lab to market survey. And I supervised a master student of computer science at Dalhousie. And we interviewed 58 Nova Scotia companies. Guess what? Can you guess the percentage of companies that aren't using cloud? Can you type in your answer in the chat? I'd like to see what your guess is. Yeah, the percentage of companies that are not using cloud in the companies, the 58 companies we interviewed. Okay. Alyssa guessed 80% are not using cloud. Rishi guessed 90%. Will guessed 0. 800%, Sophie. I guess you were trying to say 80%. Okay, perfect. Pendong gave 0. The correct answer is 0. Surprisingly, all the 58 Nova Scotia companies are using cloud, but they are using cloud at very different level. Some companies just started using cloud, very little involvement on the cloud. Some companies are 100% on the cloud, like DeepSense. DeepSense develop all their projects on the cloud, right? It's 100%. So 0% of companies are not using cloud in Nova Scotia, at least for the companies we interviewed. It's surprising, right? And we also asked the companies some questions. Do you think cloud is secure? Please think about this in your brain. I'm going to give you the answer. Do you think cloud is secure? Okay. The answer, most people answered yes. Next one. What's your biggest concern of using cloud? Yeah, just to think about it for, say, a few seconds. What's your biggest concern of using cloud from the point of view of industry? If you are, say, a manager or a CIO or CTO in a company, what's your biggest concern of using cloud? Okay, most people answered cost. Why do we ask these two questions? Just in about 2 years ago, the top 2 concerns from users about cloud, that is security and the cost. Security was at the top and the cost was at the second. Recently, we found the trend changed. The top one is the cost and the second one is the security. I'm going to explain more about the cost and the security later. Okay, have you considered sustainability when using cloud? Everyone answered no. So no one has considered sustainability as a factor when they use cloud. Actually, this is very important. This is very important when industries use cloud. So when we use cloud resources, we use the resources remotely. In Canada, we have 3 regions of data centers. say, offered by AWS, if we use AWS as the example. So the three regions are in Toronto, Montreal, and a very new region in Calgary. So when you use these resources, you are using them remotely. So you don't have anything running in Nova Scotia. So if we are very selfish, we can say that we are doing very good for the environment for Nova Scotia, right? Because we are using the resources in Toronto and Montreal or in Calgary. But you know what? If AWS wants to construct a region or data centers in Canada somewhere, AWS has to propose how they are going to generate the power, what kind of power they are going to use. They will try to use the green power for the electricity, like Google has huge amount of solar panels to generate the power. So if they are not environment friendly, their solution is not environment friendly, the local government won't approve their proposal. So when you use cloud computing, actually you are doing good things for the climate change, and you are reducing the carbon emission. Okay, so what is cloud computing? I want to just very briefly explain this. Cloud computing is the on-demand access of computing resources, servers, storage, software, AI-powered tools, and more over the internet with pay-per-use pricing. So basically, you are using remote servers, remote hardware, software, and the network resources. The major technology of cloud computing is virtualization. Due to virtualization, tenants can share the resources, and you can shut down the resources anytime. You can start resources anytime to save money. That's why we say it's pay-per-use pricing. The benefits of cloud computing, there are lots of benefits. One is cost savings, because it's a pay as you go. So you only use it, you only pay for what you used. It's not like, we have so many idle computers in the government buildings, on their housing campus. Professors apply for their research fund and buy a lot of machines for the research group, but actually 80% of the time, those machines are idle. So they are using power, they are using AC, they are generating carbon. So it's definitely not a cost-saving way when we use on-premise data center or on-premise physical machines. And the cloud computing is very secure. I'm going to explain that later. And it's very flexible. You can use a machine with 2 CPU today, but you don't like it. You think it's not powerful enough. You can just shut it down without paying more money. And tomorrow you're going to use 4 CPU machine. It's very flexible. And scalability is one of the major reasons people use cloud computing. So when our students at their housing register their courses on February 26 at 10 o'clock in the morning, they just did that last week. It's very easy that the server crashes, and a lot of students cannot register their courses. So this has been there for many years. What's the problem? It's the scalability. We know on that day at 10 o'clock, so many students are going to register for the courses. However, we only have 1 or 2 servers. Our servers cannot scale out. So we cannot get, say, if we have more requests, we should get more servers. That's the scalability. On the cloud, you can preset how many servers we're going to have for tomorrow's course registration. After the registration is done, we can scale in. That means we can reduce the number of servers. So scalability is very important to accommodate the different numbers of requests from different from users and from different communities. And it increased the collaboration because everyone can access cloud from everywhere in the world. So when your team, which is around everywhere, almost every single continent on the globe, you can always collaborate on your work using the cloud by setting up appropriate permission, you can just access the stuff you can access. Automation is a very, very important component of cloud, because when we say, for example, if we want to design and implement our end-to-end data analytics pipeline on the cloud, we can automate almost everything from the data ingestion to data processing or data analytics, and finally, data visualization. It can all automate it. It saves time, and automation has another very big benefit, that is you can avoid a lot of human errors because it's automated, it's written in script. Disaster recovery means when you have a disaster, it's very easy for you to recover from the disaster. Say if you have a disaster in the local data center, it's very hard to recover. So on the cloud, we always have redundant resources. Your data say your data is stored in the region of the data center of Toronto. Your data is replicated 6 times. So you have 6 copies of your data, and they are stored in different data centers. So you don't know this. You think you only have 1 copy of your data, but actually by default, they can save your data as 6 copies. So say if the data center in Toronto crashes, you lose your data in Toronto, but you still have 5 copies of your data in other cities. So those the data center in other cities will automatically fail over, and you can still access your data without any loss. So you don't even notice this. You don't know what's happening behind, but you just use your data as usual. So this also relates to the next point, loss prevention. You won't lose your stuff because you have so many backups. And number 9 is managed services. Managed services means we don't need to worry about the patching, upgrading of the systems. Say if you have a virtual machine, you have to upgrade the machine, upgrade the operating system. If you want to install some libraries, you have to upgrade the libraries, etc. But if you are using managed services, like if you use managed relational database service, you don't need to worry about anything about the hardware, software upgrade, etc. You only worry about your data in that database. It's all managed by the cloud providers. Competitive edge. So edge computing is very, very important and popular right now because data centers could be far away from your data. Say your data is in Nova Scotia, but the data center is in Toronto. However, the cloud providers provide edge locations. The edge locations is much closer than the data center in Toronto. So it's closer to you, to your data. So when you do the computation, your data will be sent to the edge location. So the latency would be very good. Sustainability is I just explained, it's going to be more and more important in the future because our government is very urge every industry to think about their carbon emission when they develop their products. The misunderstandings about the cloud computing includes some people think it's cheap, some people think it's expensive. It can be as cheap as $1 a month if you just use cloud computing use cloud to host your static website. It can be very, very expensive if you generate huge amount of data. So you should not say, draw the conclusion very easily, cloud is cheap or cloud is expensive. It's always case by case. You need to analyze the use cases, but one thing you need to always keep in mind is that you have to have professional persons to analyze the cost of your cloud services. You can save a lot of money. Like a project I've been supervising, we had to spend about $5,000 a month at the very beginning. We didn't spend the money. That's when we designed our architecture for the company. The estimated cost is was $5,000. After we optimized the architecture, and we tweaked the requirements from the users, and we also tweaked how we are going to use the database. It is at least 50% cheaper than we originally planned. So you need to have professionals to do the calculation and change and modify, improve the architecture for your application on the cloud. You can save a lot of money. Some people save 90% of their cost by changing the architecture of their application on the cloud. Some people think cloud is not, the second one is not as secure as on-prem. That's not right. Most people we interviewed already answered that it is secure. Cloud provides way more security tools than on-premise machines. So you can use those tools to secure every single layer of the architecture on the cloud. And some people think it's easy to config. It's not easy to config, but it's easier compared to a physical data center. If you are managing a physical data center, it's very hard to config. It needs a lot of professional knowledge, a lot of experiences, but still, cloud is not that easy to config. Some people think cloud is limited for user control. Actually, that's not right. Cloud provides users fine-grained access control. You, as a system admin on the cloud, you can give users all different kind of permissions or the policies for the access control of different resources. And some people think it's not reliable enough. Actually, cloud is very reliable because of the high availability. Like I said, your data is not in this data center and is replicated and copied to other data centers. You don't even know that. So it's very reliable. Some people think it's not suitable for enterprises. It's only good for personal uses. That's not right. I'm going to show you in a few seconds which big companies are using cloud. And some people think cloud storage simply means Google Drive or OneDrive. Google Drive and OneDrive are cloud storage, but for industries or enterprises, cloud storage, you should not use Google Drive or OneDrive for your storage because Google Drive and OneDrive cannot be integrated with other cloud services and to form a pipeline and to resolve your issue. For example, when we do data analytics, we need to do data ingestion. And then when data is ingested into the cloud, we want to, that's a new event. We want to do some data analytics. We want to trigger the events to make the data analytics happen automatically. After the data analytics is done, we want to trigger another event to make the data visualization happen automatically. Using Google Drive or OneDrive, you cannot make this happen because Google Drive or OneDrive is for personal uses. So if you want to design your enterprise level or the applications for your businesses, you should not use Google Drive or OneDrive. There are professional cloud storage, including object storage, hard drives, and network shared file systems. Let me show you who are using cloud for their businesses. You can see there's so many big names here, right? Netflix, Twitch, Airbnb, McDonald's, they are using AWS. And you can also see the customers by industry here: computer software, IT, retail, finance, hospital, internet marketing, insurance, real estate, others. Basically, almost every, you can find cloud usage from any industries who are using Azure and GCP. We know AWS, Azure, and GCP are the three major cloud providers. You can see these big names. I can tell you that these names are not complete. There are way more names who are using the cloud provider, the cloud services of these three cloud providers. So what can industries use to do their work using cloud services? This is where we think the innovation can be done, right? So the main use of cloud computing is file storage and sharing. Like I said, cloud storage is different from Google Drive and OneDrive. So when you store your file on the cloud, you will have a lot of features for your files, say versioning, delete control, MFA, event-driven. When there's a new file comes into your storage, there could be an event-driven generated, and the next step will be happening automatically. The second one is data ingestion, analytics, and visualization. This happens very often in industry right now because industries have huge amount of data. They really, really want to store their data, to ingest their data from their local machine or sensors, edge devices, IoT of things into the cloud, because only when after they are stored in the cloud, you can make the pipeline work, analytics will be done next, and then the visualization. The charts will be shown on the dashboard automatically, and the different users can be configured in your team. The users can be configured to generate the visualization by themselves using the same dashboard. The third one is data backups and archiving. The cloud storage not only provide you to store your files, they can also provide you the backup solutions and the archiving solutions for, say, as long as dozens of years. And disaster recovery, I just mentioned, and software testing and development. On the cloud, you have the full set of CI/CD and DevOps tools to implement and test your software. And then also you can deploy your software onto the compute platforms like Kubernetes, container services, some container orchestration frameworks, etc. So it's just like previously when you did your software development using your local machine and Git tools to automate the whole process. On the cloud, we can do the same thing. The next one is we can do machine learning model development, integration, production, and management using MLOps, using the other tools provided by the cloud providers, say SageMaker from AWS. We can easily make our machine learning model training flow from the data ingestion and our code input our code into the notebook, and then just hit a few buttons, our model will be trained. And after our model is trained, we can generate an endpoint of our model for the very convenient and easy to use from all different parties. Just hit that link and provide the data. You can generate the result from your model. This is not easy to implement on your local machine. And people use virtual machines, which is called infrastructure as a service, IaaS, or platform as a service, PaaS. PaaS means you have your data, you have your code, but you need a platform to run your data and code. You can just use PaaS. And for social networking, for content delivery applications are like Netflix and YouTube. So content delivery is a very important application or use case on the cloud, because there's so many content delivery companies. They allow users to upload their videos to the servers. So when users click those videos from different places all over the world, how do we ensure that the latency is good? How can we ensure that users can access the videos very quickly? That's content delivery network using caching technologies and the edge computing I just mentioned, and IoT. So for ocean companies, if you have Internet of Things, the sensors and edge servers, or whatever edge devices you have, if you want to communicate with the cloud, cloud provides a whole set of tools to manage your sensors, to communicate with your sensors, and can deliver your machine learning models to your sensors. For your sensors, to run the model locally on the edge devices. So that makes the running of your model very, very quick because it's locally on your device. It's not on the cloud. So there's so many use cases for industries using cloud. So if you want to innovate the using the cloud services, you do need to think about all these like from storage to compute to database to network to software development to machine learning, and also to the edge and the IoT stuff. It covers almost everything. So at DeepSense, what can we do? We support ocean industries, and we support ocean industry AI projects that has been happening for a few years. We have developed so many AI projects for ocean industries. And we also provide data readiness projects. Say, we help you collect, clean, analyze, and process your data and visualize your industry data. Without data, you cannot do anything on your AI projects. So if you don't have data, if you don't understand your data, you should talk to us, and we will help you to prepare your data for the next stage, for understanding, for training your data and get the insight of your data. And we also have cloud readiness projects. So if you are not on the cloud yet, or you just started using the cloud, you still have a lot of confusions, we are going to help you migrate to the cloud and set up the environments. So if you are not an ocean industry, so you are not supported by DeepSense, but you don't need to worry because I'm teaching multiple cloud courses at Dalhousie, our Master of Applied Computer Science program. We have a lot of good students who have pretty good cloud background and software development background. So our students can help you on cloud migration, data ingestion and visualization, machine learning, cloud engineering, cloud development. So if you want to develop your application on the cloud, and the cloud architecting. So if you already have your applications, you want to architect it on the cloud. So our students can also help you. So if you are from the ocean industries, please contact info@deepsense.ca or me to discuss the possible collaborations for your projects. If you are not from ocean industries, you can contact me so we can sit down and see what your requirements are. So I can introduce my students to work with you, either like a co-op student or part-time student, part-time employee, or even full-time employee. That's all from me. So any questions?
Thank you, Dr. Yang. Yeah, we'd love to open the floor up to some questions. You can either pop them in the chat or in the Q&A box. I can start us off. I know I have a question. What are the potential challenges of implementing cloud technology solutions in our industry specifically?
I think the biggest challenge is that we don't have enough professionals. During the interview with those 58 companies, I found that a lot of companies, they just make use of their current employees because a lot of people know IT, right? So they just tell their IT people, can you learn cloud and set up our cloud environment? And then we found that, oh, there are so many things they set in the wrong way. They even didn't know when they set up the cloud on AWS or Azure, they can apply for a very big credits. They didn't know that. That's a very big waste of money, actually.
Okay, interesting. Any other questions from our audience? I don't see any right now in the chat, but can give people a couple minutes to gather their thoughts. Still don't see any. Oh, there we go. We've got one from Amy. When you say 0% of companies do not use cloud, does this include companies that only use OneDrive or Google Drive?
No, when I said that, I mean every single company is using cloud other than just OneDrive or Google Drive. They use some cloud services. Maybe they just use the cloud storage, not OneDrive or Google Drive to store their data and back up their data, or they use some virtual machines on the cloud. Some companies like from very small startups, just having 1 or 2 persons to big companies like Canadian Tire. Canadian Tire are using a lot of cloud services on the cloud, but still, they are still using OneDrive and Google Drive, but they also use a lot of other cloud services.
Awesome, thank you. Sophie's got a question. Would you recommend any courses to those who are interested in learning more?
Yeah, if you are interested in learning cloud, if you want to learn basic cloud concepts, I think Udemy is the best resource for you to learn. There are different levels of courses from the beginner's level to associate level and to the professional level. You can choose the ones you like. And if you're a student at Dalhousie, say if you are in the Max program, you can learn the courses from me.
Awesome, thank you. And Recruit's asking how cloud computing will influence industry in the future, and how will it impact job functions and required skills?
Yeah, that's a good question. I think, in that hype cycle, you can see AI and the cloud are the two major technologies that will be coming in the future. But why AI is, everyone knows AI. AI is so hot, but few people know cloud is also very hot, because AI is used by everyone in our daily life. So we use ChatGPT, right? But for people who are using cloud, people didn't notice that when you use Outlook, the email client, you don't know you are using the cloud. And a lot of people using cloud are the professional people, like Procruit actually. You set up the cloud, you do a lot of things on the cloud, but you're professional people. But most people are not professional people. They don't know cloud is actually everywhere. So in the future, I think the job functions and required skills, the impact from cloud will be impacted by AI. AI will change a lot. Of course, AI also will change cloud. So AWS already provided some AI tools when architecting your applications on the cloud. It's going to remove some roles on the cloud, but it can only assist the persons to architect their applications. It cannot replace all the people who architect their applications on the cloud. The required skills, I think architecting skills is still very important.
Thank you. And we've got one more question from Nangia asking how the 58 companies were selected for that study. Were they randomly, and were they from different sizes of companies and different industries? And they also say, wonderful and informative presentation. Thank you.
Thank you very much, Manja. So those companies were randomly selected. We just went through our LinkedIn connections. We asked almost every connection if you want to be interviewed. So we didn't have any preferences on the companies. Surprisingly, all of them are using cloud. We interviewed companies include, I mentioned, Canadian Tire, and also like TD Bank, RBC, Dalhousie. Dalhousie has a plan to move to the cloud in the next 10 years. I know it's very, very long because Dalhousie is too big. The migration will be, it's a massive migration. It has to be done gradually, slowly. We can see so many companies are moving to the cloud because they don't want to host their own machines, hire people to manage the machines, worry about the power, worry about the AC. So using cloud, you can eliminate all these concerns.
Okay, awesome. I don't see any more questions, so I think we'll wrap up. Thank you again for taking time out of your busy day to join us, Dr. Yang. And as someone without a background in computer science, that was a very informative presentation and it was very digestible. And I feel like I kind of understand the cloud better now. I've dropped a couple links in our chat for our student pool and our mentorship program called STEM Connector. It's a Flash mentorship program, and if you're interested in connecting with folks working in the ocean sector and other STEM fields, sign up today. It's all free. It's a Flash mentorship program, so it's very low commitment. You can connect with lots of different mentors, and it's more one-off meetings. And if you enjoyed today's discovery session, we have lots of other discovery sessions available on our YouTube channel. I dropped the link for that as well in the chat and all of our social medias. And keep an eye out for more discovery sessions and events from us. Our next discovery session will be in April. Hasn't been announced yet, but keep an eye on our social media for registration for that. And Dr. Yang, if you have any final words before we wrap up.
Oh, thank you, everyone, for coming to this discovery session. If you have any questions, if you want to discuss more topics, feel free to reach out to me or Deepsense. And thank you very much, Alyssa, for hosting this event.
Awesome. Thanks again, everyone, for joining us, and enjoy the rest of your day. And we'll see you at our next discovery session. Bye.
Bye-bye.